we need to find whether the given series converges or diverges. Since we're given that we start from, I hope you can read this, from k equals 2, you should already be suspicious and already say, maybe I can use the integral test for this. And it turns out you can, because for the integral test to work and to be able to tell you something, you have to have 1 over something, and the something has to keep increasing, so that the overall function keeps decreasing and going towards 0. And we have that here, because 1 over something big is going to be 0. And that's why 2 is given, because if you graphed this from, if k is on the x-axis, from k equals 2, the function would keep decreasing. It would look like this, sort of, if this is your plane. And then we need to find the area under the curve to see whether the function converges to a value or whether it goes towards infinity, which means that it diverges. Right? So we're dealing with an improper integral here, because we need to integrate from 2 to infinity, right? In the curve, we need to integrate all the way until the end. And so we look at this as a function. So 1 over k ln k cubed. And there is a nice way to go around this, which is to rewrite this as limit as k approaches infinity. Sorry, not k. I'm all in k world. As b approaches infinity, and notice what I'm going to do now, the integral from 2 to b. So I have basically replaced infinity with b, and I have said that b is going towards infinity. So this is now legal. This becomes legal. And yes, I still have to integrate this with respect to, I forgot it here, with respect to k, so dk. The way to integrate this is just standard substitution. I make u be ln k cubed, and so, oh sorry, not ln k cubed, that would be ridiculous, ln k, and so du dk is equal to 1 over k. Therefore, dk is equal to, what did I write here? X? K, I meant k. dk is equal to du times k. And so we can substitute this dk here with this, and that will come useful because then you can cancel out the k's. So what we have now is, I'm just dealing with the integral, from 2 to b of k du, right? That's this thing. dk is k du, or duk, doesn't matter, over k u cubed, because I have substituted ln k as u, right? Or u as ln k. And now, conveniently, these cancel out, and I get that the integral is in fact so if I put this up as u to the power of minus 3, then I end up with u to the power of minus 2 over minus 2, right? This from b, or from 2 to b. And now we go back into this notion with the limit. I'm going to remember the problem. I don't have any space. I have to push this up. And so we're now in limit as b approaches infinity of this, which is ln k to the power of minus 2. So you can rewrite this as 1 over ln k squared. And minus 2 stays at the bottom. So we actually have minus 1 over 2 ln k squared. And into k, we will be putting b and 2. Now this is very important, so we don't need this anymore. Now, what do I do? Limit as b approaches infinity of, and now we're just dealing with this as we always deal with integrals, as if this limit here doesn't exist. That's why I skipped it here, because it's otherwise too confusing. And so limit as b approaches infinity of, and now we just plug it in, 2 ln squared b, yeah, minus 1 over 2 ln squared 2, which is of course plus. And because we put infinity into b, and this is obviously 0 because it's minus 1 over, yeah, ln of infinity is theoretically infinity, and then infinity squared is infinity, and 2 times infinity is infinity, and so minus 1 over infinity is 0, and so you're only left with 1 over 2 ln squared 2. And that here is the answer to the integral that we were finding. So the integral of this, we have kind of escaped this infinity notion with this b. The integral from 2 to infinity of this is this. And because this is a fixed value, that means that the area under our original curve, which I have erased, which looks something like this, I suppose, that the area is actually finite. And so from that, we can conclude that by integral test, the sequence that we were given, oh sorry, not that one, this one, it converges by integral test.